technical subhead of ME-RISE. As the saying goes, the only thing that is worse than starting something and failing is not starting. Startup Day is a celebration of those developers who do not fear the failure, instead, come up with new innovative ideas for the betterment of the society. As a part of Startup Day celebration, ME-RISE Malad Enclave for Research, Innovation, Incubation, Startup and Entrepreneurship, which is the official wing of Malad College of Engineering, has organized a talk where the young and enthusiastic developers of NAIN-funded projects will be sharing their knowledge and experience throughout the journey of their project building. Now I request Ifna, Vice President of ME-RISE, to welcome the gathering.
Good morning, all. I am Ifna, currently pursuing my fourth year in the program of Triple E. I am delighted to welcome you all to this event. It's my pleasure to welcome Dr. Geeta Kiranye, Professor and Head of the Department CSC, Coordinator of ME-RISE, College Coordinator NAIN, who constantly support us in all aspects and is also an excellent motivator and inspirer in the most positive way. Welcome you, ma'am.
Thank you, Ifna.
Next, I would like to extend a warm welcome to the students who will demonstrate the NAIN funded project to us. Welcome you all. It's my pleasure to welcome faculty point of contact from all the branches of MCE. Welcome you all teachers. My warmest welcome to all the ME-RISE members who have worked diligently to make this event successful. We are pleased to have the students present to make this event a great success. Thank you, everyone.
Thank you, Ifna. Now I would like to welcome Geeta Kiran ma'am.
Sure. Thank you, Anaga. Good morning, all. I heartily welcome you all to this India Startup Day. We all are aware that small steps lead to a great path. Yes, we need to dream big, but how to put small steps cautiously to reach the big dream. In the same way, the small steps laid down from 2018 has led to a path with great learning and doing things out of the box. Our Honorable Prime Minister Narendra Modi has rightly termed startups as the backbone of New India, and it is prominent for us to encourage the youth to see entrepreneurship as a prime career option. We have come only a little way in bringing innovative ideas to reality. This way is our stepping stone to help the young minds venture the entrepreneurial journey. We at ME-RISE are working towards solving the needs of society, integrating possible technology, and building business acumen at the campus. In this forefront, I'm happy to inform that ME-RISE has established itself as a Section 8 company, as a non-profit organization where we could help students by funding for their projects. And its objective of promoting startups and providing adequate facility that will enable them to be creative and innovative in identifying great business opportunities. With patience and perseverance, today we are here celebrating India Startup Day and showcasing innovations done by our young innovators. Today, our proud students, your seniors, are exhibiting our prototypes funded through New Age Innovation Network, a Government of Karnataka initiative. From here, we have a long way to go, working on scaling up the prototype, building up good business model, and sustaining the products in the competitive market space.
ME-RIISE promises to bring your ideas to reality, mentor your path in shaping your careers with an entrepreneurial mindset. What we wanted is young minds with lot of interest and perseverance to work in solving community problems and address the needs of the society. We are here to guide you, mentor you, help in pitching your ideas and turning them into possible businesses. I hope here we do have some first year students also. If not, please convey them. We had done all the process of, it could be bridge course, it could be the design thinking laboratory, the credit course what we had, and it was all the idea what we had, like where we could pitch our ideas and write proposals to. It could be MSME, it could be New Age Innovation Network, it could be Smart India Hackathon. So wherever we get shortlisted or get selected, we can get funds. So yes, of course, some of you had pitched for Smart India Hackathon. Will not lose hope. We'll go with some more government of Karnataka initiative or government of India initiative. Now, before October 10th, we have to send proposals for New Age Innovation Network, that is government of Karnataka initiative. Yes, we with all these ideas will propose these ideas to New Age Innovation Network, and they are going to fund 3 lakhs per project. So with lots of hopes, let us pitch our ideas and try to get funds from New Age Innovation Network. So you could see there now the students, the speakers, the project team members are going to present their prototypes to you all. So please listen cautiously to them. You can also get inspired by them, and you can also get funded from New Age Innovation Network. So please make best utilization of this event. Ask others also to join in time. Please put up the message to your friends. Always try to maintain time. Okay. Thank you all the best.
Thank you, ma'am. Now I welcome Nikhilesh, third year CS, Assistant Event Manager and Editorial Subhead of ME-RIISE, to continue with the session.
Good morning. Yeah, the words of Geeta Kiran ma'am were very inspirational. Now we have a project that one of our seniors is going to present. That was an AIM funded project. So I would like to call upon Ifna K, final year CS, final year Triple E, to present her project. Before that, let us see a brief video on how her project works.
Okay, good morning everyone. Before starting, let me share the screen. Okay, I hope everyone that my screen is visible.
Yes, the screen is visible.
Okay, so coming to my project that is called Solar Panel Cleaning Robot. So this is a system for remote and automatic cleaning of a solar panels. So most of us, everyone are known that global warming and climatic change, these things are threatening the future of our planet. So finding sustainable ways to meet energy needs is becoming increasingly important. So one of the most important ways of moving towards a renewable and non-polluting energy resources in order to generate electricity using solar panel to harness the sun's energy. As we can see that in solar panel there is no any moving parts, hence solar panel are one of the most coefficient and low maintenance ways of generating the electricity. So this is how exactly the prototype of solar panel cleaning robot looks. Let's go to the abstract of invention. So the actually the reason why we developed this robot was to just design and development of this solar panel cleaning system. So the main objective of this prototype was to clean the solar panel by using some sort of electrical mechanism such that the efficiency of the system or the solar panel will not be any compromisable. So we can see that the solar panels are exposed to the environment. So because of that, all sort of dusts, water, rainwater particles, and the bird droppings that will be accumulated on the top of solar panels. So frequently cleaning of the solar panel manually would be very difficult, and it would have been taken lot of time, and even cost would be have become increased. So for that reason we have used a special wiping material in order to clean the solar panel, and hence by increasing the quality of cleaning. Next, coming to improvisation. So most of us, everyone are known that in like in the very previous years, like long back ago, the wheel used to manufactured by using stone, but now we can see that the wheels are manufactured by using tires. So this improvisation from stone to the rubber tire have been tackled many problems, and hence they have come up with a product. So there have been lot of innovations and problems in the same way. Before manufacturing this solar panel prototype, which is presenting on the left side, the solar panel robots that are presenting on the right side, these were manufactured in the in before years. Like these were the products. There were many problems that we got to face during manufacturing these product. That is, it some of the brushes that we used in the manufacturing in the previous years that used to cause damage to the solar panels, and we required lot amount of internet, which would have been a very high cost. So by tackling all these problems we have come up with a new prototype. So this solar panel, how this is different from all other three is, um, we have used two brushes, that is one to clean the dust and another is used to clean the water particles that have been present on the solar panel. And these brushes are developed in such a way that it does not cause any sort of damage or destruction to the solar panel present. And we are not using any sort of internet, rather we are using Bluetooth Wi-Fi module, and the output produced will be in the more amount as that of the input we receive from the from the sunlight on the solar panel. So next let's go to the block diagram. So the internal structure that we have shown, this is how exactly it looks inside the solar panel cleaning robot, and this is the block diagram of the solar panel cleaning robot. Here we have used a buck converter. Buck converter, it is a device that is that increase the efficiency of a system. What it does is it converts high voltage into low voltage, such that it also helps to increase the battery life and by reducing the excess heat in the system. So next we have used a solar panel. So here solar panel that we have used is let me show you, is made up of microcrystalline solar panel. In this we have used PV system of solar panel. So this what it does is, so this PV system, what it helps to do is, the amount of sun rays that we get from the sun, that much energy will be converted into electricity. So there will be no amount of decrease in the efficiency, or the output that we get to see will not be any will not be any deduction. So that is the reason we are using monocrystalline solar panel system, and the efficiency of the system is also very high. So for that reason we are using this system. Then coming to the PV cells, That is what we have discussed right now. Next, we have used here lithium ion battery. Why we have used lithium ion battery is because we can see there are many batteries that are available in the market that require separate charging system. But coming to lithium ion battery, it does not require any sort of charger system or anything. This is mega popular and it is very commonly available. And coming to the motor driver, it is a bidirectional motor that we have used in this system. Then the proximity sensor, it is the sensor. What it actually does is, we can see that here there is a ring shaped yellow color top. So once the robot starts to move, when it this proximity sensor, it sends information to the robot that above this point there is no any further path. It says the robot that to return back to its original position. So this proximity sensor, it sends the detection without coming in touch with that. So this is how exactly the robot solar panel cleaning robot is manufactured, and also it consists of a sensor that tells the motor only to rotate the brush only in the solar panel region. If this brush rotates apart from solar panel region, the cost efficiency or the efficiency of the system will be get reduced. And also the solar panel cleaning robot will be attached to the solar panel system itself, so that it gets charged by the solar energy, and there will be no required of removing the solar panel, keeping it aside and charging it for a later. Then why actually we have designed this product is, so while designing solar panel, most of us we have faced installation problem, that is the cost. So we thought of reducing the cost so that it would be very like while launching the product in the market, so most of the people should be able to purchase the product. So in order to reduce the cost, what we did is, instead of installing many number of solar panels, why don't we reduce the number of solar panels and increase the efficiency of the solar panels. From that we can reduce the cost of solar panels, and also it will have a positive impact on the environment. That's it. Thank you.
It was a very intriguing presentation, Krishna. So I have a few questions regarding your project.
Yeah,
So
sure.
what did you face any problem that inspired you to do this project, or were you fascinated by the technology involved itself that you started doing this project?
Actually, this project, one of our seniors started this project as they have got graduated from the college. They have passed this project to us. And we actually, from our department, we had a visit to solar panel near Hole Narsipur. There we got to see there were large number of solar panels attached, and also we got to see that there were many dust particles and all those things got accumulated. Hence, by going through all these reasons, so we got a very good project. Hence, from that knowledge, we started to started like implement doing this kind of implementation in the project.
Uh, that's nice. As you said, microcrystalline solar panels are very efficient and coordinated with your project. But is your project also able to clean the solar panels that are already present, or is it necessary that the solar panels that we use are microcrystalline? Do you have any plan to use upgrade it so that it can clean the solar panels that are already present?
Actually, what the thing is, we are trying to start a company both by manufacturing the product and also the solar panel. Hence, the thing is, why we are using monocrystalline cell is that because solar panel nowadays, most of the solar panels that we have used is amount of energy that drops, like amount of solar energy that comes from the sun and it drops on the solar panel, that much output we are not getting right now. That is the major problem we are facing. So in order to increase the efficiency, we are planning to implement a monocrystalline solar panels. So that it is also one thing what we got to see is its durability is up to 50 years.
Well, it's a very good idea to start a company that manufactures both solar panels and cleaners. So, do you plan to make it available only for commercial use where a large number of solar panels are present, or do you also have a plan to make a smaller version of it which cleans domestic solar panels?
So making these kind of solar panels like for domestic use, the cost will be very high. So what we can get to see is in our house or domestic purpose, we use small number of solar panels, not that much big. So manually cleaning it might it would be very good according to us. Our major focus was towards large solar power plants where we get to see large number of solar panels that have been installed. So our main target is like cleaning solar power plant which have been which have been implemented in very large amount.
Yeah, that in itself would be a very big market, I guess. And the design of the cleaning robot is very attractive. So,
Yeah.
is one design enough to clean all shapes and sizes of solar panels, or do you have to customize a cleaner for every type of solar panel?
Actually, since this is just a prototype, we have designed right now just to clean our single solar panel. We are still trying to do many more implementation using this. There are still many problems like it needs to complete cleaning all the solar panels that are present over there. So for that reason, we are still planning to do some more implementation before launching that thing to the market by doing all sort of research and everything.
Yeah, that's very nice. Thank you very much for this captivating presentation.
Thank you so
So,
much.
I would like to open it to all our audience if they have any questions regarding the project. So, let's move on to the next project.
Okay, thank you.
I would like to call upon Chayang, third year ECE, to present his project, automated drip irrigation system. Before that, let us have a glimpse of how the project looks with a video.
Good morning. So we are from Department of Electronics and Communications. The main title of our project is Automated Drip Irrigation System. So the main problem formulation we took up was to irrigate the field. So as the water need is increasing day by day, so we need a proper water management system. So that is the reason we have used various sensors in our project, and using these sensor data, the actuation occurs. As you can see, this is the main working model of our project. As my friend said, these are the hardware requirement needed for our project. So these partition includes the 3 field. We have divided this, and these are the moisture sensor we have included. And so each field contains the temperature sensor, and for the dripping for the each field we have used a motor and a solenoid valve to pump and to inlet the valve. And also we use node MCU as a controller, and to detect any type of plants decay smell or any type of gas, we have used the methane sensor, so that it will send the message or the notification for the farmer. And also in this field we have included the light in comparison with the incandescent bulb. So this will heat up the plants when the temperature becomes less than the threshold value. And here each moisture sensor value sends the moisture content of the different fields, so that the farmer can assess that automatically water supply for the each field or the required field. And also we use the solar panel for the power supply when there is no power. As you can see here, there is a fan to lower the temperature of the plants. When the temperature rises above the threshold value, this fan will automatically gets on and reduce the temperature of the field. Let me show the working of our project. As I said, this is the moisture sensor which is controlling this field. So as I said, there is no conduction taking place here. So this means the sand is dry. So the motor is on. So the water will be drip in this process. So when we connect this, now there is a conduction wet and the conduction in the wet sand. Now the motor is off. The drip will be stopped. So this is the function of the moisture sensor and the motor. This lead to the drip irrigation. So as I said, when the gas detects, it will sense the methane and the buzzer gets on. So in the same process, this will send data to the cloud and the farmer can get the notification in his mail or in his application.
That was a small glimpse of the project. Now I would like to call upon Chayan to continue.
Good morning. Hello, everyone. I am Chayank, third year from Department of Electronics and Communication. As you know, our project name is Greenhouse Automation using drip irrigation. The main reason behind doing this project is, as you know, due to increase in the population, demand for food requirements in a day-to-day life. As we know that as you know, in multi metropolitan cities, the agricultural land is very less, and to increase the yield of crops per hectare, we are using greenhouse automation technique. Let me explain first what is greenhouse automation. Basically, the greenhouse automation means uh, hello, am I audible?
Yes, you're audible. Continue.
Yeah, wait, let me share the PPT. Is PPT is visible?
Yes, it's visible.
Yeah. Let me explain what is greenhouse automation. A greenhouse is a formed structure with walls and roof made with transparent materials such as grass or plastic roof in which plants will grow in a regulated climatic condition. The greenhouse material used here are plastics and glass, which are designed to hold the heat inside. It may be cold weather or the greenhouse will provide a nice or warm environment. See, this is the main internet. This is the Internet of Things where these are the problems faced in this generation, where due to lack of agricultural land and due to increase in pollution and population, we came up this idea where a crops can be grown in a isolated area to yield the good crop per hectare. So the main components used here are, one is, this is called as Node MCU. It's the microcontroller which contains an Wi-Fi module present in it, where all the sensors are connected to the Node MCU. We have used multiple Node MCU. The multiple Node MCU are connected to the Arduino or Raspberry Pi. For Arduino, we can use C programming to write the code, whereas for Raspberry Pi, we can use Python. This Node MCU has an inbuilt Wi-Fi and which is connected via internet. Basically, it is an ESP8266 Wi-Fi module. Next, this is soil moisture sensor. The soil moisture sensor you can see here there are two pencil-like structure which is inserted into the soil, and the soil moisture level is measured through it. The digital values will be sent to the cloud, and we can see the values in the mobile app or application. This is called moisture or humidity sensor, where it detects the moisture present in the air and amount of temperature at present condition, what is the present temperature in it. It measures that, and we can see these values in through IoTs or through IoT. The values are noted in backend servers, and which can be accessed through mobile. Then this is called as relay. This relay is used for regulating the power supply to the motor. Then this is called as sinusoidal valve. This allows the disengages the water flow through the ground. This is the main block diagram of our project. Here it is. This is called as this is the microcontroller node MCU ESP8266 we have used here in our project. Then we have used several sensors like temperature sensor, soil sensor, and humidity sensor. And these sensors are connected to the internet via Wi-Fi. And these sensors values are noted in the server's backend database, where this database helps in storage and regulation of storage and analysis of the data of the two different grounds of the land when we use for cultivation. And these values can also be observed through mobile Android application, where farmers can easily sit in home and control the ground using mobile application through internet or Wi-Fi. Then this is the main block diagram of how we connected the other sensors to it. This is the microcontroller where temperature sensor, humidity sensor, and soil sensor are connected to the microcontroller called node MCU. Then this node MCU is connected to the Wi-Fi module and Arduino Wi-Fi module. As these multiple of, as you know that a land will be more than 1 acre or 2 acre. So as you know that the range of the Bluetooth and Wi-Fi module will be less. To increase the range, we have used repeaters of my node MCUs. So multiple node MCUs are connected to the Arduino or Raspberry Pi. Then the power supply is given to the each node MCU through battery or through a single power supply. And these applications and values are noted in the cloud, are seen in cloud and mobile application through internet. So let me give an example that how our project works. Consider that there are two fields. This is field A and this is field B. As you know that we have used soil sensor, which sense the moisture of the soil. Let me see that. You can see here that in field A, first the sensor will sense the how much moisture present in the soil. If the moisture value is high, or if it's in normal condition, the valve will be off. If the moisture content is very low, automatically the water supply, we have used the sinusoidal valve, which automatically gets turned on, and the valve gets open and water is supplied to the ground. Next, same like that only, we have used temperature sensor. If the temperature is too high, automatically that the fan gets turned on and which cools the environment. Whereas if the temperature is low, the fan will be turned off. Whereas in other condition, if the temperature is very low, the bulb gets automatically turned on. In small scale, we have used bulb. Whereas if you need in a large scale, like more than 1 acre to 2 acre, we can use heaters to heat up the environment. And these databases and these values are reportedly collected in the cloud, and we can see through the mobile application, where the farmer can easily regulate and operate the operating system by just using the Internet of Things. Where here we have used UB dots for example. Here we have used for our project, we have used UB dots, where we can easily access through the internet when it's connected to the internet or through Arduino or Arduino or Wi-Fi module. If these digital values will be stored in backend sensors, and it can be used for analysis. Here we have used the main advantages of our project is, see, this is the node MCU. This is called as ESP8266 module, and this is called as sinusoidal valve or motor. And here we have temperature sensor, humidity sensor, and soil sensor. This is ground A, ground B, and ground C, as our seniors explained in video. Same like that only. Then these are the instruments we have used for our project. The main advantages of our project is that it creates and maintains an ideal environment for managing environment factors including heat, humidity, and temperature. And it's an energy consumption method. The energy consumption is very less in this project, and the quality of yield will be very good if you maintain if you maintain at regular water supply, and if you measure the what is the content of the soil, water content in the soil and moisture in air, and we can regulate it, and it can be the crops yield will be very good. Then farmers can control the greenhouse remotely. They do not need to visit the ground frequently. Then the main as you know that if you do one project, there will be both advantages and disadvantages. The main disadvantages are the sensors cannot malfunction at any the sensor can malfunction at any time, so frequent maintenance is required. The continuous electricity and water supply should be there. As you know, in villages, due to poor development, the water and electricity supply will not continuous. Instead of the another one main disadvantage is that instead of connect, as you know that every farmer cannot afford internet. So instead of internet, we can use, instead of node MCU or Wi-Fi module, we can use alternative as GSM module, with where this GSM module uh, can be used the alternative as an Wi-Fi module, where a SIM card is inserted to where a SIM card can be inserted to the GSM module, and the farmer can get the SMS through his mobile. But if you use GSM module, uh, the water supply cannot be controlled manually. The farmers need to control it by seeing the SMS or messages. Thank you.
Thank you, Chayan, for enriching our knowledge regarding agriculture and IoT with your project. So, with increasing urbanization, do you think there will be an increasing need of greenhouses and automation for the development of agriculture and for sustaining uh, high yield in
High
small
yield
lands?
in small lands. Yes, because available land is becoming less day by day. We need greenhouse to increase the crops per hectare.
Yeah. And we saw that you mentioned too many sensors that you are be using to control the environment of the farm. So
Yes.
can you list a few sensors that you are using and what would be the cost and how they would work to let us know more about IoT and sensors?
Like we don't know the exact cost, but we have used like price is economical, not so costly that mediocre farmers cannot afford.
Yeah, that would be a very good thing. It
Yeah,
was a
Nikhilesh,
very
I
And in
guess
intriguing
large scale,
presentation.
but to implement in large scale, we need more investment.
Yeah,
yeah, Nikhilesh, I guess the thing with IoT projects is as the number of products we make, as the quantity of products we increase, the production is increased, the cost will obviously come down.
yeah. With mass production, of course, the cost will be down with, regarding any product, right?
Yes.
Yeah. Thank you for a very captivating presentation. Next, I would like to
Thank you.
call upon the project Tesla Road. Before the presentation, let us see a glimpse of how the project works. Now I call upon Tarun, final year CSE, to let us know more about his project.
Hello, good morning.
Hello. Yeah.
Hello, am I audible?
Yeah. Yes, you are audible.
Good morning, everyone. Our project is Tesla Drone, which is a medical purpose unmanned aerial vehicle, more properly known as drone. We have created this for medical purpose, like to deliver medicines in emergency crisis, in ambulance, which take more time to reach the destination. Our main objective is to supply medicine to the patients in an emergency situation as early as possible. To fulfill this object, first we collect location of patient at the and the required medicine through the app we have developed, and we create the path for drone to reach the destination and deliver the medicine and return to its launch position for next trip. Let me share you. This is the picture of our prototype drone. Like we have used a flight controller called Pixar, which controls each and every actions performed by our drone. And it is an autopilot drone, so no need to human intervention during the flight. And we have used the brushless DC motor, which give more thrust when compared to the normal DC motor. And we have used ESCs, which is an electronic speed controller, which controls the speed of the motor for the required situation. And we have used the 3300 mAh lithium ion battery for powering. And this is the drone cycle. First, we will collect the information from the patient or the consumer, and it is a drone is reloaded for the drone is loaded with the medicines, and we can answer the call like we have given number to emergency calls, and we notify our drone team to send our drone to the to the given location from the user, and we monitor each and every movement of our drone through the app. This data is transported from 433 hertz megahertz telemetry, and this is how it looks while we are collecting the data. This is the user interface of our app. Let me show how our drone works through simulation. See, now this is the present location of our drone. Like we have already given the plan to our drone to go to some location and deliver the medicine. Only we have to do the action, give the command to our drone. It automatically take off, and we can see the altitude of our drone here, which is rising now. We have given altitude for 50 meter, just to avoid any trees or building near us during the flight. And here we can see the speed of the drone. Now the drone is going to the location. Now the deliver has been completed, and it is returning to its original position through RTL mode. Through this, we can deliver our food and food or medicine to the patients or consumer within a particular time, limited time. Thank you.
It was a nice presentation, Tarun. So, recently drones have been in a lot of limelight, and they have become very popular in many different fields. So how did that help you during the building of your prototype, or how do you think it will help you in the future production of such drones?
See, like drone, we have faced many problems while making this prototype. Main was the frame construction. We have taken consultant from an open source like Mission Planner and Arduino Pilot, which have the pre-defined codes. Through that, we have achieved this project.
Yeah. So you said frame construction was a very big challenge. Do you think 3D printing would be a good solution for such production issues?
Yes, it will be more useful. Like we can reduce the weight of the drone if we are 3D printing the frame, but it matters the strength of the frame. It depends on the strength and the material to be delivered. It depends on the weight, how much weight we are delivering, and the strength of the product we have used for 3D printing.
Yes, let us hope that we get a good technology that could develop better drones. And often we see ambulance stuck in traffic trying to deliver blood or deliver organs for transplantation. Do you think your drone could also carry out such transportation during emergency situations?
Yes, we can easily transport from one area to another area more in a faster way than the ambulance can reach.
And do you have any future plan to expand your project to not just medical, but many other fields? Like drones are useful in many other fields, right? Like agriculture, or it may be for transportation and other things.
Just like for agriculture, for pesticide spreading the pesticides through the drone, and also for delivering food like Zomato delivery, we are planning on that.
Yeah, and even nowadays, forest fires are also being extinguished using drones. So I think drones have a very good future perspective, and it will be a very big market.
Yes, it will be a big market.
Thank you for the presentation, Tarun.
Thank
Now
you.
I would like to call upon Achal J, final year CSE, to present his project Automated Mopping Device. Before that, let us have a glimpse of how the project works.
Hello, I am Anirudh. The project is Wi-Fi control cleaning robot. I am the leader of this project. The key features of this project are it is simultaneous mopping and sweeping device, and we have used Node MCU DC gate motors. This is sanctioned by New Age Innovation Network. This is the project. This is Wi-Fi control cleaning robot.
Hello all, I'm Chinmay Ashankar. The parts we have used in this device are Node MCU as the microcontroller since it has built-in Wi-Fi module and a vacuum cleaner, and the diaphragm-based water pump, and we have also used 4 150 RPM DC gear meters and the lithium-ion-based power plants.
Hello, I am Ajay. Let's see the working of the device. As the title implies that it's Wi-Fi control, we have a Wi-Fi connected to the MCU, which is the device. The overall control of the device can be controlled to this application, and the movement can be monitored to this. It has all 4 dimensions of movement. The chassis is built on the ACP sheets, which is also called as aluminum composite panel. It's called such because it's a mixture of aluminum and composite. Aluminum provides the structure and strength for that, and the composite binds the aluminum together. And we have used this because it's waterproof. Then moving to the working of the device, the overall movement is controlled by the application itself. And we have the vacuum cleaner fixed in the front of the device. We have a rotator shaft along with a motor, which sweeps the floor. And we have a water pump to control the flow of water. Since it's a wet cleaning device, the flow of water can also be controlled through that. And we have driver motors in between the node MCU, the controller, microcontroller, and the driver and the motors, that is DC 150 RPM motors. We are using motor drivers because the power supply of node MCU is typically 5 volts, but the motors require around 9 to 12 volts. Thereby, we are using a motor driver which converts the power from the battery to the motor. And yeah, this is a simultaneous sweeping and mopping device. Yeah, thank you.
Yeah. Now I would like to call upon Achal to tell us more about his project.
Yeah. Could you please share the screen? Okay. Now, when coming to the project, my project is a Wi-Fi controlled cleaning robot. Basically, now you might have seen that in large areas where there is a lot of need of continuous cleaning and there is a lot of foot traffic, we could expect a lot of dust. And so, to do that, we have built this Wi-Fi controlled cleaning and mopping device. As the name itself says that it's Wi-Fi controlled. This was built by me and my team, Anirudh and Chinmay. So under the guidance of Dr. Geeta Kiran ma'am. Can you please go to the next slide? Yeah, we have. As you know that cleaning is a very tedious job and it's too monotonous. So for efficient cleaning and mopping of the area, we have created a Wi-Fi controlled cleaning robot, which is more feasible than manual cleaning. The robot is actually the problem is you know that manual laborious and cleaning and mopping is not so efficient. So with the help of a robot, we scale up things and build a very innovative and efficient model. Next slide, please. Next slide, please. What made us decide if made us do this project? Every problem will be every solution will have a problem. So the main problem what we saw is lack of efficient manual cleaning processes and recurring labor costs, non-availability of labor, no simultaneous sweeping and mopping device. Non-availability of laborers, no simultaneous sweeping and mopping device. Frequent non-effective ways. So when we all see that okay. As I told that there are a lot of existing devices. So let's see what are the disadvantages of those devices. Many related appliances from various companies have been followed, but what we observed from these devices is firstly it's too costly and not much compatible for Indian users. As we all see that in our Indian homes or even offices, we could see a lot of Indian touch to our infrastructure. Example, there might be a small door hump which you find near the doors. So those kind of obstacles could not be passed by a device which is already existing in the market. So we have built a device with more ground clearance so that these kind of door humps could be passed easily. Later on, we have devices. These kind of devices do not even support simultaneous sweeping and mopping. In Indian cultures and what we follow is generally we sweep the floor and then mop the floor. But these devices which are presently in the market, they do use they vacuum the devices, vacuum the floor, and then mop, not in the same order. They reverse those. So what we thought is building the product with an Indian touch so that it's suitable for Indian market. Next slide, please. Yeah, we could find out a lot of literature surveys where there were a lot of devices existing in the market, but yeah, we had to mix up 2 or 3 research papers and check whether this solution could be solved. Next slide, please. Okay. Our main aim is it's a Wi-Fi control. Why is it Wi-Fi controlled and not automatic control ones? Because there are scenarios where we would like to clean only certain parts, certain ground areas of the floor. So at those situations, we can't just program the automatic cleaning robot to just sweep and mop that certain area. So what we did is we have a Wi-Fi control so that that place can be cleaned and mopped. Later on, it can also be used in large areas like human hazardous areas, industries like nuclear power plants, chemical plants, and where there is a lot of dangerous gases going on. And we have all faced COVID, and I guess cleaning during COVID was very essential and involving lot of manual personnel would be risking their lives too. So we could use these kind of devices where it can be we could save lives from this. Next slide, please. Yeah, the objectives were to increase the efficiency and reduce water consumption. Yeah, this is a major concern what we see. In India, we see a lot of areas where there's a lot of rain and a few areas where there is drought. These kind of in these kind of drought areas, we have to utilize water in a very efficient manner. So this device can reduce the water consumption by 50% and can cut down the recurring labor costs. It can also reduce the time of cleaning the area, and it can, as I told you, it can clean and mop the floor simultaneously. And as we can see that even you might have seen in your homes that certain places of your home are more dirtier than other places. So there has to be some reason why those areas are more dirtier than the other areas. So these kind of things can be monitored using our device, and yeah, we could check where more dust is getting accumulated and fix a problem for that. We have a methodology for that as you can see in the figure. Next slide, please. List of components and their specifications. So we have Node MCU, what we have used primarily. It's a Wi-Fi development board based on CP2102 IC. Then we have a 100 RPM 12 volt DC geared motors. As you can see that many of us are not built to be exactly straight. So there might be small slopes. So to avoid those things and to prevent the robot from rolling over backwards, we have used DC geared motors so that it's not going to roll over and it can resume the cleaning from that place itself. And we have motor drivers. Why do we use motor drivers is as you know that Node MCU has just an input power of 5 volts and we can't be running a 12 volt DC geared motor using a 5 volt input. So we are bringing in the DC, we have a DC motor drivers so that it can transmit the power from the battery using the controls provided by the Node MCU to the motors. We have a diaphragm based water pump. We have track wheels for pivot motors. And the wheels, the specialty of the wheels which we have used is these wheels do not leave any scratches on your floor. This is also a disadvantage of making devices which we have in the market. Then we have a vacuum cleaners, mounting clamp for the DC gate motors, and voltage boosters. Next slide, please. Yeah, this is the 3D view of the device. As you can see that there's a rotary shaft in the center of the device fixed for the mopping, and we have a water pump situated in the front of the device, which sprays water. And before this, the floor is mopped. We have placed the vacuum cleaner in the frontmost of the device so that it's vacuumed first and then the floor is mopped. Next slide, please. We have found out references where we could relate it to our more product project. So yeah, that's it from my end. Thank you.
Thank you, Achal. So I would like to know from where did you get the inspiration to develop this project?
It has been and cleanliness has been a very a prime concern for us. So we feel that cleanliness has to be efficient in an effective manner. So we implement these kind of devices in hospitals where there is I mean threat to human lives. So instead of deploying humans we could use these robots where they could clean the floors more in a convenient way and in an efficient way with less time, less water.
Yeah, I think it's very important in today's world, especially post-COVID, to have such automated cleaning robots. Uh,
Yeah.
would you like to enlighten us about the process of prototyping so that we can know how the prototyping is done and what are the steps?
Yeah, basically, when it comes to these kind of devices, the main structure of the device stands on the chassis of the device. As you all know that the chassis of the car, we all see that, right? So the same way, the main challenge was to find a material which was suitable for our requirement and which suited the functionalities of what we actually wanted to do. So we brought an APC sheet with a lot of research. APC sheet is it's called as aluminum composite panel, ACP sheets. What these do is this aluminum provides the strength and structure for the board, while the composite material binds these. And one more advantage of this is it's economically very low, and you can easily get it. And we even thought of we are reducing the water usage and all. So it has to be environmentally friendly. This panel what we have used is 100% recyclable. So yeah, we found out that device, and it's a hardware device, and we had to build everything from the scratch. Even the chassis is built by us. As you've seen in the video, it has two steps. The first step was for the movement, which provide the structure, and the second step had all the components placed on it. And ACP sheets is one more advantage is it's waterproof. We have a lot of water involvement in that process, so we could not use any wood to so we had to come up with this ACP sheet. This was the most critical, I guess, critical part of that, and the payload weight.
Yeah.
Whether you're I would like to. I think that my friends who have done the drone project would also have faced the same thing. The payload weight has to be kept as low as possible. If we increase the payload weight, the power required to move the device will be more, and the power requirement and the battery more. So to tackle that, we had to use this ACP sheet, which acted as a you know base for the device.
Yeah, I think it plays a critical role in energy efficiency, right?
Yeah, right.
Yeah, and you said that you have used Node MCU as the microcontroller in your project. We heard that in other projects
Right.
that presented today also have used Node MCU. So would you like to tell us what is
Right.
Node MCU and how it works?
So basically, Node MCU is a microcontroller. Okay. Why we use Node MCU is because if we use the other kind of microcontrollers, the problem with them is there's no Wi-Fi model or module integrated with the microcontroller. But Node MCU is one such microcontroller where the Wi-Fi module is also integrated into the microcontroller. So it does eat up, data flow. And we need not make additional uh, modules and module connections between the microcontroller and the Wi-Fi module. It's an integrated one. And yeah, it requires just 5 volt of power instead of other Raspberry Pi and all. They require more power. Microcontroller comes to chips and microcontrollers. The main efficiency lies in the uh, how well it's insulated and how well it has the thermal capability. I guess Node MCU has that good. So it doesn't heat up much, and when it doesn't heat up much, we get the benefit of efficiency.
Yeah, so I think it's the perfect microcontroller that serves the purpose here.
Yeah, I'm not saying that my Node MCU is the best, but for different projects, as per the requirements, we found Node MCU
Yeah.
useful.
So your project would have a very big scope in domestic households, right? So what do you
Right.
plan to have the cost of that product when you make it available to the customers? And what was the cost of the project when you were prototyping it?
Yeah, I would like to. This is a very good question. I would say that when you're building something from the scratch, we blew many things while building it from the scratch, and yeah, it was a nice experience building such. And I feel that the prototype we have experimented a lot. We have bought all kinds of devices. We have bought all kinds of motors and tried and tested them if it suited to our requirements. So we were able to shortlist few of the devices, few of the equipments what we needed, and that made our prototype cost skyrocket. But when it comes to the mass production or implementing it to the market, giving it to the market, I would say that it's very less. It's going to be much cheaper than other devices which are presently existent in the market. So I would say that yeah, the prototype cost is more, and as the number of mass as we implement mass production in our project, as we mass produce equipments, we could really bring down the costs.
Yeah. So what do you think is the future perspective of your project? Like, would it be just for cleaning floors, or would you also use it for other purposes?
Yeah, right. I got similar idea. See, example, we all know that how in corporate worlds you have seen that in the Windows sills are present, right? They
Yeah.
in those high-rise buildings, it's not feasible for a man to go there and clean, and the place is dangerous to his life also. So we could leave this device so that you can clean it remotely, and there's no lives at stake, right? So this one application is what I thought, and there are many other applications which can be implemented, and with the implementations of new equipments to the same device, we could even extend our vision of applications of the same device.
Yeah. So from the very first day, robots have been doing the work that are not possible for humans or reaching the places that are unreachable by us. So it would be a very good application, I think.
Yeah, Nikhilesh, right.
Yeah. And do you have to program your device so for a particular environment, or do you just produce the same prototype for everything and it adapts to the environment?
See, yeah, as I told, I gave you example of Windows Hill. Windows Hill uh, width and uh, information to the device. Device of by of the same same proportions, or it would not clean the entire surface if it's a automated cleaning robot. But since we are using a Wi-Fi controlled cleaning robot, the device can be controlled in all four directions. It is the front, back, left, right. So I guess there would be no situation where it's not landing. It's not. You can really steer it any way you want.
Yeah. So I think that gives a very Indian touch to the project because most of them are
Yeah, right,
automated and they have their own flaws.
right, right.
Thank you, Achal. It was a very nice presentation and we learned a lot from it. Next, I would like to call upon Tarun, a project that is Bhuvan RJ, to explain his project vision. Before that, let us have a glimpse through the video.
ಲಾಸ್ಟಿಗೆ 4 ಮೆಂಬರ್ಸ್ ಸೈನ್ ಅಪ್ ಆಗುತ್ತೆ. 4 ಮೆಂಬರ್ಸ್ ಪ್ರಾಜೆಕ್ಟ್ ಮೆಂಬರ್ಸ್ ಫೈರ್ ಇಮೇಜ್ ಇರುತ್ತೆ, ವಿಡಿಯೋ ಇರುತ್ತೆ. ಸೊ ಫೈರ್ ಇದ್ದಾಗ ಇದೇ ಬ್ಲೋವರ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ವಿಂಡ್ ಇದ್ದಾಗ ಫ್ಯಾನ್ ಇದಾಗುತ್ತೆ. ಇವಾಗ ಏನು ಹೇಳ್ತಾರೆ ಅಂದರೆ ವಿಡಿಯೋ ಗೇಮ್ ಇರುತ್ತೆ, ವರ್ಚುವಲ್ ರಿಯಾಲಿಟಿ ವಿಡಿಯೋ ಗೇಮ್ಸ್ ಇರುತ್ತೆ, ಕುತ್ಕೊಂಡು ಅದಾದರೆ 80 ನಿಮಗೆ
Good morning, everyone. Yeah, Nikhil.
Yeah, go on.
Yeah, good morning. I'm Bhuvan. So my project is titled as Vision. The basic idea behind the project is to feel things rather than just seeing. You saw the demo, like I'll explain about it a bit later. I'll share my screen for starters. I guess you can see the PPT.
Yeah.
Okay. Like I said, like I was saying, the main goal or abstract of a project is to see things feel things rather than just seeing them. The core of our project is ML part. We have trained a neural network to detect certain scenes. For example, like if you're watching some video, let's say you're watching a movie. We have trained a model right now to detect fire and water, I mean rain. So if you're watching a movie and there are some scenes which have fire, for example, people sitting around a campfire, then the model would detect the fire and give a certain output. If there is rain, the model would detect the fire, I mean, detect the rain, and it would give certain output. That output is captured by an Arduino Uno board. We needed a bit more processing power, so we went with Uno. That board is then like it gives it the output is carried out by the board, Arduino board. So basically, if there is fire, as you saw in the video, there was a hair dryer which usually gives out hot air. So we used that represents fire. So the board activates, I mean, switches on the hair dryer whenever there are scenes of fire involved in the movie. And when it's rain, we actually we didn't show it in the video as it would get messy. We added micro sprinklers which would switch on whenever there's scenes of rain. So that would give you more realistic feels. I saw all the projects discussed till now. They were all like environmental friendly, and they were doing some cause. They had a cause, but our project is like basically a luxury project. It doesn't solve any issue. Although we first had in mind, what we had in mind was to give a sense of feel for blind people so that they can enjoy the movies a bit well. But on realizing that that's a very niche market and we couldn't capitalize on that, we switched our goals to mainly movies and games. We focus mainly on VR games, as VR games tend to offer more feelistic approach. So we could increase the ongoers experience by just like adding creating a whole room or a whole setup where there could be all kinds of equipments that would feel like starting from fire, rain, wind, like all the things that could be felt in the game could also be felt by you. There's a lot of scope for this project in gaming right now. So we deviated from the original market. This is the model creation process. First, we acquire images, then we pre-process. As we like initially, I mean, it's still ongoing. We have not yet trained the model right now, but this was okay. I would like first like to tell that this is not our project. This was a senior's project. They figured out all the IoT based part, but they couldn't quite nail the ML part. So, and yeah, time was up. They were graduated. So, I mean, the project was passed on to me. I'm working on the ML part basically. So, this is how we create the model. We acquire images containing fire, we pre-process them. This is not actually my flowchart, so I didn't use a spike data set. I used a YOLO v5 model. Then we trained the model. Then I got the model. Then testing takes place. So basically, output is if there's heat, we turn on heater. If there's rain, we turn on sprinkler. If there's wind, we turn on fans. I'm currently not working on wind as it's quite hard to visualize wind. We had to come up with some other ways. Right now, it's not the time is not feasible, so I'm not working on wind. This was the prototype. As you can see, there's an Arduino Uno. We all know what relay is used for. It's just used to manage power supply. Arduino Uno is the plug actually is for the dryer to be connected into, and the motor should be replaced by a micro sprinkler as we are advancing in the project. The fans are basically useless right now, so yeah, that's pretty much my project. This is the software part. As you can see, the frame contains fire, and the terminal there's output saying heat, and in water it tells rain. So that was the software part that the seniors failed to implement. This is the preliminary model. Thank you, guys.
Yeah, the video and the presentation were very interesting. So was the name Vision. So we hear the term machine learning a lot these days, and neural networks, heuristics, all have been very much popular recently. So the term neural network sounds very fancy, but basically solves a lot of problems. So can you enlighten us more about neural networks?
Neural network is nothing but layers of simple, like, basic models, right? For example, let it be KNN, K means clustering, linear regression. Those are like the basic models in machine learning. Neural net is just, it comprises of many layers of the same. That's it. So it takes, there's something called hidden units, which are actually what processes your data set or the whatever you give in, and they pass on to the next layer. So each layer has some kind of feature extraction that enables the next layer to work on the previous features and finally give you an output. So basically, to summarize, a neural network is collection of mini networks. That's it.
Yeah, and you said your project is in a very niche market. Do you think that in today's theme parks and amusement parks, there are shows that perform like there are 8D shows or there may be 5D shows and VR games? What do you think the technology that they are using, and how is your project different from that?
So I thought this question would come up as I used this as my pitch when I was pitching to other kids. This was my selling point. So basically, whatever you see in amusement parks and VR games, they are pre-timed. It's something called the pre-timed. That means they know what happens everywhere. I mean, at what time what happens. So, for example, if there's a fire, they know it's exactly at 2 minutes 30 seconds, so they pre-time all the stuff to happen at that time. But ours, like, if you sit on the system which we develop and play any video, any movie, there's no need to time it. It's like happens simultaneously as you're watching the video. The model detects and then the output is given to you right there.
Yeah, that's a very big plus point, I guess, because we observe that they play the same video every time because the hardware is customized to that. Now
Exactly.
we could give customers a choice, right?
Exactly.
Yeah. And would you like to explain more about the software part regarding which programming language you have used or what is the environment you have used?
Basically, it's Python. It's very easy to implement a YOLO V5 model. It's the currently all the image image detection are done through YOLO models. So basically, that's the trending image detection model right now, and it's very easy to implement. That's why I used YOLO. I used Python because YOLO V3. I mean, the versions below V3 were implemented on C, but after V3, it's only Python. So I used Python.
Yeah. So thank you, Bhuvan. It was a very interesting one, and we learned a lot from it.
Thank you,
Yeah.
Nikhilesh.
So now we are coming towards the end of this session. Now I would like to call upon Sukshita to give a vote of thanks.
Hello all, I'm Sukshita, editorial subhead at ME-RIISE. It gives me immense pleasure to meet such aspiring young engineers and get to know about the NAIN funded projects. I thank Dr. Geeta Kiran ma'am for being with us and creating such a wonderful platform to inspire budding engineers to come up with new innovative startups. Thank you, ma'am. I thank the project team members for their valuable time, and I also thank the members of ME-RIISE for their valuable support. Last but not the least, I thank all the participants for attending the event and making this successful one.
Thank you, everyone. Have a nice day.
I hope this was a very informative session and many of us would be inspired to do such projects and learn from it. Uh, Thank you everyone for attending the session. Now we are going to end this session. Thank you.